square matrix, the RREF of a square matrix is identity matrix. When this happens, suppose that I am taking a square matrix A, which is a square matrix of order n, that is n by n. And when this happens, that is I am reducing it to RREF, when will I get identity matrix of order n? For example, I am taking a random matrix 2, 1, 3, 0, 1, 2, 3, 1, 1, 1. Okay. So I have to convert this matrix into reduce the row echelon form. So for that, what are the operations we have to apply? First of all, we have to make the leading coefficient as 1. To make that leading coefficient as 1, I am interchanging. We can interchange R1 and R2, right? So this becomes 1, 2, 3, 2, 1, 3, 1, 1, 1. So now we can mark the first leading coefficient and make all the entries below that as 0. So this will be R2 changes to R2 minus 2R1 and R3 changes to R3 minus R1. So this becomes 1, 2, 3, 0, minus 3, 0, minus 3. So sorry, it is not minus 3, it is, yes, it is minus 3. 1 minus 4, that is minus 3. Next element, that will be 3 minus 6, right?
Minus 3, sir.
Minus 3, okay. And what is R3? That will be 0, minus 1, minus 2. Now what? We have made the first leading coefficient as 1. Also, the vertically down element is 0. Now move on to the next leading coefficient, which is minus 3. We have to make this leading coefficient as 1. So you can see that in the second row, there is a common factor minus 3. So we can cancel it out. So we can use the operation R2 equal to R2 times 1 minus 1 by 3. So this will make 1, 2, 3, 0, 1, 1, 0, minus 1, 2. Now mark the second leading coefficient and make all the vertically up and down elements as 0. Okay, how can we make that 0? We have to change R1. R1 changes to
2R2. No. R1 minus 2R2.
R1 minus 2R2 and R3 changes to
R3 changes to R2 plus R3.
R3 plus R2. So that becomes 1, 2, 3, 0. So first row changes, that is R1 minus 2R2. That will be 1, 0, 3 minus 2, which is 1, 0, 1, 1. Third row will be 0, 0, 3. Now we have made all the entries vertically up and down to the second leading coefficient as 0. Now move on to the third leading coefficient, which is 0. So you have to make all the entries vertically up to that third leading coefficient as 0 by using elementary row operation. So we can apply, or we can first change it into 1 by dividing R3. R3 times 1 by 3. So it will be 1, 0, 1, 0, 1, 1, 0, 0, 1. So now we can apply the operations, we have to make all the vertically up elements as 0 using the third row. So R2 changes to, sorry, R1 changes to R1 minus R2, and R2 changes to R2 minus, sorry, R1 changes to R1 minus R3, and R2 changes to R2 minus R3. So we are using the third row. So that will be 1 0 0 0 1 0 0 0 1. So now this matrix is in reduced row echelon form. So here also we got the identity matrix. So what I am asking is, suppose I am taking random square matrix and converting it into a reduced row echelon form. Is it necessary that it will be always identity matrix? If it is not, when will this happen? When we can say that a square matrix, the reduced row echelon form of a square matrix will be identity matrix. That is the relation. It happens when the rank is same as the order. That is the property. If a square matrix has a square matrix of order n is taken, that matrix is a square matrix of order n by n. It has n rows and n columns. And if the rank is n, if rank of A equal to n, if we got the rank as n, then the reduced row echelon form of this A will be nothing but, that will be identity matrix of order. So if the rank of that matrix is same as the order of the matrix, then that will be always identity matrix. This is the case for only square matrix. Identity matrix is defined only for square matrix. So we can talk about only the case for square matrices. So if we are reducing a square matrix, most probably that will be identity matrix. It will not be identity matrix when the rank is not same as the order of that matrix. Suppose we are given a 4 by 4 matrix which has rank. Rank is same as 4. Then the reduced row echelon form RREF will be nothing but, that will be identity matrix of order 4. Okay. So if we know the rank of the matrix, we can check whether it is identity or not. Okay. So consider another example. A square matrix is given, reduced to RREF. So we have to find the reduced row echelon form of this matrix. So like the first step we need to do is mark the first leading coefficient, which is 1 already here. Now we need to make all the vertically down element as 0. So the operations will be R2 equal to R2 minus 3R1 and R3 equal to R3 minus 4R1. So this matrix reduces to 1, 2, 3. There is no change in the first row. Second row will changes to 0, minus 5, 2 minus 9, that is minus 7. Okay, the third row will be 0, 3 minus 8, that is minus 5. And the next element, that will be 5 minus 12, that is minus 7. So what is the next step? You have to tell me what is the next operation we can apply.
Divide the second row by minus 5.
divide the second row by -5. Okay. We can do it like that also, but dividing with the -5 makes some fractions. You can see if you divide with the -5, this will become 1. Okay, that is okay. But the next element that will become that will become 7 by 5. That is a fraction. So if there is a fraction, it will be difficult to do the next operations. So what I am going to do is I will make the vertically up and down element as 0. First I am going to do that. So depending on the situation, we have to choose the operations. So here it will be easier it will be more easier if we first make the vertically up and down element as 0. So that is the first step I am choosing. Okay. Or either you can choose this operation also. Also you can choose R2 equal to R2 into -1 by 5. That is also okay, but it will make more difficult to convert into RREF. So I am choosing the operation. I am choosing what? I will first make all the entries vertically up and down as 0. So this will be R1 equal to, how can we convert that 2 into 0?
Yes, sir.
That is 5R2 plus 2, sorry, 5R1 plus 2R2. And also we can change R3 as R3, just subtract R3 minus R2. So this will become 1, 0. The next element in the first row, that will be 3 into 5 plus 2 into -7, which is equal to 15 minus 14, that is 1. Okay. There is no change in the second row, that is 0 minus 5 minus 7, and the third row, that will be 0 0 0. Okay. Now what? Now we need to just make only the second leading coefficient as 1. For that we will apply the operation. Which operation? R2 changes to R2 into -1 by 5. So that will be 1 0 1 0 1 7 5 5 0 0 0. Is it in echelon form? Sorry, reduce the row echelon form. No. It is in reduced row echelon form. You can see that the leading coefficients are 1, and there is no third leading coefficient. Only 2 leading coefficients are there, and the vertically up and down elements of that leading coefficient is 0. So this matrix is in echelon form, but it is not identity matrix. Why? Why it is not identity matrix? Because the rank is, what is the rank? Rank is
2.
rank is equal to 2. Okay. So the rank is 2. So we didn't got the identity matrix. We all, when we get the identity matrix, we will get the identity matrix only when the rank of that matrix should be same as the same as the order of that matrix. For the case of square matrices. Okay. So this is how we will convert a given matrix. Any matrix can be converted into reduced row echelon form. Okay. So next we are going to discuss is finding solution. Finding solution of a homogeneous system using the method. The method is called Gauss elimination method. Okay. So in the first class, I said there are two possibilities for the solution for a homogeneous system. What are the possibilities for the solution? What is first of all, what is a homogeneous system? You have to tell me what is a homogeneous system.
Set of homogeneous equation.
What is homogeneous equations?
Total
AX equal to
addition.
0.
The equation which is of the form Ax equal to 0. That is, all the constant terms are 0. Okay. Such type of equation is called a homogeneous system. So, an equation which is of the form Ax equal to 0, that is called a homogeneous system. So, what are the possible cases for a homogeneous system? If a homogeneous system is given, there are two possibilities for the solution. The first possibility is it
Zero
has
solution.
it has only trivial solution. Trivial solution means it has only zero solution. Okay. The second possibility is it has may have infinite solution. So these are the two possibilities for a homogeneous system of linear equation. So actually when this happens, when we can say that a homogeneous system has only trivial solution, and when we can say that a homogeneous system has infinitely many solutions. So for that, suppose that we are given a system Ax equal to 0, then
Sir, only dot solution.
no
Hello, what is this? Only
only
trivial
only trivial solution.
solution.
Trivial solution means that is the zero solution. For the case of homogeneous system, it has always a solution. Zero will be always a solution. That is called the trivial solution. So the two possible cases are it may have only trivial solution or it may have infinitely many solution. So suppose that we are
When value of
yeah
x must is 0, then it has trivial solution. When value of x is a real number, then it has infinite solution.
yeah that is okay. Actually, it is not real number. X is capital X means what? That is the collection of variables. Not we can't give a real value. I mean, suppose maybe if x, y, z are the variables, then capital X is nothing but x comma y comma z. That will be capital X. So trivial solution means all the variables should be zero. X equal to 0, y equal to 0, and z equal to 0. That is the trivial solution. Non-trivial means at least one of them is non-zero. That is called a non-trivial solution. So two possibilities are there for homogeneous system. It may have only trivial solution or it may have infinitely many solutions. So how can we identify it? So for that, suppose that we are given a homogeneous system Ax equal to 0. Then write the coefficient matrix. What is the coefficient matrix? The coefficient matrix will be A. Then reduce it into echelon form. Not we just need only echelon form. From that we can obtain the rank of A. Okay. if rank is if rank is same as the number of variables. If rank is same as the number of variables, then that system has only the trivial solution. If rank is less than number of variables, then that system has infinitely many solutions. So these are the possible cases for a homogeneous system. The only two possibilities, it may have trivial solution or it may have infinitely many solutions. The trivial solution happens only when the rank of the coefficient matrix, which is same as the number of variables. If rank is less than number of variables, it has infinitely many solutions. For example, Consider the system 2x plus 3y plus z equal to 0, x plus y plus z equal to 0, x minus y plus z equal to 0. So this one is a homogeneous system because all the constant terms are 0. So it is a homogeneous system. Right. Check whether it has infinite solution or not. So for that, first of all, we need to write the coefficient matrix. So what is the coefficient matrix here?
P1.
Coefficient matrix is
2, 3, 1.
that is 2, 3, 1, 1, 1, 1, 1 minus 1, 1. That is the coefficient matrix. Now what? Now reduce this into echelon form. Just echelon form is necessary. We don't need to convert it into reduced or echelon form. We just need only echelon form. So what operation we can use as the first operation?
Same.
Okay, that's better. We can interchange R1 and R2 because if it is possible to make the first leading coefficient as 1, that will be more easier. So we are interchanging R1 and R2. So this becomes 1, 1, 1, 2, 3, 1, 1 minus 1, 1. So now mark the first leading coefficient, make the vertically down element as 0. So the operations will be R2 equal to R2 minus 2R1 and R3 changes to R3 minus R1. So it will be 1, 1, 1, 0, 1, 0, 0, minus 2, 0. Okay, students, what is the next operation we can apply?
The third row, R3 becomes R3 plus 2R2.
Okay, mark the second leading coefficient and make the below entries as 0. So R3 equal to R3 plus 2R2. So it will be 1, 1, 1, 0, 1, 0, 0, 0, 0, 0, 0. Right. So what we can say? Is it in echelon form?
Yes.
It is in echelon form because the leading coefficient, look at the leading coefficient. The positions of the leading coefficients are increasing order, so it is in echelon form. And also there is a 0 row that is at the bottom of the matrix. So echelon form, what is rank?
2, sir.
Rank equal to 2 because the number of non-zero rows is 2. So rank is 2, which is less than number of variables. So number of variables is 3 here, right? X, Y, Z are the variables. So there are totally 3 variables. So rank is less than number of variables. So what we can conclude? The system has
Many solutions.
infinite solution. So it has infinite solution. So we need to find out at least one solution. So there are many solutions. I'm asking you to find out at least one solution for this system. So how will you find that? So to find one solution, I'm just going to take free variables. So what is a free variable? Okay, we know that there are three variables here, x, y, and z. To identify the free variable, what we are doing is look at the column at which look at the column at which there is no leading coefficient in the echelon form. So this is the echelon form, right? So which column doesn't have a leading coefficient? The first column have a leading coefficient, right? The first leading coefficient which lies in the first column, the second leading coefficient which lies in the second column, and in the third column there is no leading coefficient. Am I right?
Sir.
Okay, so the first column actually represent the variable x. First column represent x, second column represent y, and the third column which represent z. So the column at which there is no leading coefficient is the third column. So third column actually represent the variable z. So the free variable will be z. Z will be the free variable because there is no leading coefficient at the third column, and the third column is represented by the variable z. So z is the free variable. So we can arbitrarily substitute any values for z. We can give any values for z to get a solution. We can give z as 1 or 2 or 3 or whatever value we can give to z. So I am giving z as 1. Just giving 1. Okay. So now we are using the second row. The last non-zero row in the echelon form. What is the last non-zero row in the echelon form? 0, 1, 0. That is the last non-zero row in the echelon form. So from the second row, we will get the equation. What is the equation corresponding to that row? Each row represent an equation. From the second row, what is the equation? The equation corresponding to the second row, which will be 0x plus 1y plus 0z equal to 0. So 0x plus y plus 0z equal to 0. That is the equation corresponding to the second row. So that means what? Y equal to 0. Okay, we got the value of y. So if z, we have given z as arbitrary value, z equal to 1, y equal to 0. Then we will move on to the next row. Next row means the preceding row. Preceding row is R1. So from R1, we will get what is the equation corresponding to R1 in the echelon form.
X equal to 0.
Not x equal to 0. Look at the first
Also,
row.
x plus y plus z equal to z equal to 0.
Yeah, x plus y plus z equal to 0. Okay, that is the equation corresponding to the first row. So we know the value of z equal to 1, y equal to 0. So x plus 1 equal to 0, that means x equal to minus 1. So we got a solution. So a non-zero solution for the given system will be x, y, z will be equal to, what is the value of x? X is minus 1, and the value of y, which is 0, and z is 1. So actually this system has infinitely many solutions. We just find one such solution. One such solution is x, y, z equal to minus 1, 0, 1. Okay. If we substitute z as 2, z as 2, we will get another solution. If we substitute z as 3, we will get another solution. So by defining the value of z,
It's
we will
according
get
to our will, sir.
what?
It's according to our will. The XZ value changes.
Yeah, you can give any values for z. Depending on the value of z, we will get different solution for the system. So infinitely many solutions are there. One such solution will be x, y, z equal to minus 1, 0, 1. So this one is a solution. Okay. So how will you find the general solution? That is the next question. If there are infinitely many solutions, we can find the general solution of that system. General solution. We can identify the general solution by, okay, we know what is a free variable. Free variable, here the free variable is, z is the free variable. Then the variables which are not free variable is called a basic variable. So what are the basic variables here?
X and Y.
X and Y are the basic variables. So what to find the general solution, what we are doing is we will express this basic variable in terms of free variable using the echelon form. So look at the echelon form. From the echelon form, we will get the equations from R2. From R2, what is the equation? The equation is nothing but y equal to 0. So we can't change y. Y is always 0. So move on to R1. So from R1, what is the equation?
X plus Y plus Z equal to 0.
X plus y plus z equal to 0. So we will express this x in terms of the free variable. Okay. So x equal to minus y minus z. Y is always 0. So 0 minus z, which is equal to minus z. So x equal to minus z. Y equal to 0. And z is the free variable. So the general solution will be x y z equal to x y z equal to x is what? X is minus z. Y is always 0. That is 0. And z equal to z is itself because it is a free variable. So we can get the general solution in terms of the free variables. Here z is the only free variable. So we can find out the general solution in terms of the free variable. Here the general solution is minus z, 0 z. So if we need to find out a particular solution, substitute values for z. For example, if z equal to 1, what is the solution? The solution will be minus 1, 0, 1. Okay. That is what we got when we substituted z equal to 1. So if we substitute z equal to 2, what is the solution?
Minus 2, 0, 2.
When z equal to 2, solution will be minus 2, 0, 2. When z equal to 3, solution will be minus 3, 0, 3. So there are infinitely many solutions. That solution will be depending on the values that we choose for z, because z is the free. Okay. So to find the solution for a homogeneous system, what are the steps? First of all, we have to write the coefficient matrix, then reduce that coefficient matrix into echelon form. From the echelon form, we will obtain the rank of the matrix. If rank is same as the number of variables, then it has only trivial solution. The solution will be 0, 0, 0. That will be the only solution.